All right, problem 7 takes us back to a quadratic. Again, the domain for all quadratic functions, negative infinity to positive infinity. Our range is not going to be negative infinity to positive infinity. We'll take care of that in a moment. To find the x-intercepts, I want to find where this is 0. So I could try to factor, or I could use the quadratic formula. In this case, it doesn't have integer values for x-intercepts, so the quadratic formula is going to be the way to go. So remember the quadratic formula, it says x is the opposite of b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to do that on the bottom where I can have a little bit more room. So my function again is negative 2x squared plus 4x plus 3, where this is a, this is b, this is c. So I take the opposite of b, negative 4, over 2 times a plus or minus the square root of b squared minus 4 times a times c over 2a. So I get negative 4 divided by negative 4 plus or minus square root of 16 minus negative 24 over negative 8. And I'm going to use my calculator. So I'm going to get that ready as I finish up simplifying. Negative 4 divided by negative 4. Hopefully we can all figure that to be 1. Helps if I do the right thing here. This shouldn't be negative 8 because a is negative 2. I think I was already multiplying it when I said negative 4. Plus or minus negative 16 minus negative 24 is 40. So my x values, if I just use my calculator and I'm going to round to a decimal place or two, so I have 1 plus the square root of 40 divided by negative 4. And that gives me negative roughly 0.6. So that's one of my solutions. And for the other solution, I'm going to do the same thing, except instead of plus, I'm going to subtract. And I get about 2.6. So those are my x-intercepts. Another important point in a quadratic function is the vertex. So we're going to find the vertex. The vertex is actually part of our quadratic formula. One of the reasons I like writing the quadratic formula this way, if I can get this to stay, that is the x value of my vertex. So if I go back to where I did my work, the x coordinate for my vertex is 1. To find the y value, I plug 1 into my function. So I find what is f of 1. So 1 squared is 1 times -2 is -2. 4 times 1 is 4. Plus 3. That gives me a total of 5. So my vertex is at 1, 5. And then I'm going to cross the x-axis down below there. So that vertex is actually a maximum. My y-intercept with a quadratic is always going to be this value for c. So my y-intercept is 0, 3. And again, you could just plug 0 in as well and get that same value. Using the vertex, because that's where the axis of symmetry is, I have a mirror image point. Again, I could find other points by using the shotgun method, but I'm going to get this quadratic function. Now, the only thing I haven't done is my range. The range, well, my maximum value is 5, so I can be anything less than it, or I could be equal to 5. And there is that quadratic graph.